Alright, CNT140, we're looking at Chapter 12. Now we're going to get into a little bit more specifics on the fiber optic cable itself. Okay, so one of the first things they mention is the optical fiber itself, and hopefully I should remember some of this from 120. The optical fiber itself is designed to carry light, and the fiber itself is made up of two main parts. This piece of glass out here is made up of the core and the cladding. And you can almost think of the core as a super clear glass, and the cladding around it is, I hate to say, roughed up, if you will, but it's a different index of refraction. So it's designed, the cladding is designed to refract the light or bend it back into the core of the fiber. And the core of the fiber is the part designed to carry the light. So you can almost think of this as the cladding like the straw, and the core is like the hole in the middle. And the idea of the straw is to carry water, and the hole in the middle is where the water travels. That's kind of how I visualize it in my brain. Well, if I take a look at the fiber itself, if I look at it a little bit further, a little bit better than the picture they show you, here is actually the main parts of a piece of fiber that you guys would most likely encounter. The outside jacket, if I cut that off, that's your plastic insulation on the outside to protect the fiber. The first thing I encounter is these strength fibers. And these are typically Kevlar strands. Kevlar for super strength. It's not bulletproof. I like to joke on that. But it's there for strength. That way, as I'm dealing with this fiber and installing it, there's something there to keep it from stretching and breaking. As I cut that away, I actually have the glass stub itself, and the glass stub itself is made up of two main parts. This actually has labeled the coating, but the two main parts are the core in the center and the cladding around it. So those are the main parts of my fiber. As we meet it for class, I'll show you examples of that, and hopefully you remember from 120 seeing examples of that when we had class before. So the fiber itself, there is actually different types of. There is single mode and multi-mode, and if I break down multi-mode, I actually have two different types of multi-mode. So let's take a look at these different types of fiber. Here is multi-mode step, multi-mode graded, and single mode. Well, let's take a look at these. The multi-mode itself has a rather large core. Again, you can think of this as a nice big fat straw, kind of like the McDonald's milkshake straw, if you will. Nice open core in here to allow light through. And my light source for these up here are typically LED light source. So I actually have multiple rays of light, multi-mode, multiple rays of light, multi-mode, multiple rays of light, multiple rays of light leaving the LED, and as I look at the step index here, the light itself is kind of bouncing its way down the fiber. With the multi-mode step index, there is a rather large difference in the indices of refraction between the core and the cladding. So you could almost think of them like almost like a mirror. There's a drastic difference between the core and the cladding. So as the light tries to leave the core, it hits the cladding out here, and it literally reflects, bounces right back into the core. So you could almost think of this multi-mode step index like taking a straw and putting BBs down it. The BB is going to bounce its way down the straw till it comes out the other end. And those would be the rays of light, the multiple modes of light. And don't get bent out of shape when you see these multiple rays of light. Don't think of this as sending, 4 different data signals down here. No. Remember, we're sending a pulse of light down the fiber, then we stop and send nothing. The pulse is a 1, and I stop and have no light, that's a 0. So pulse 1, nothing, 0. Pulse 1, nothing, 0. Well, that pulse of light that goes down is made up of multiple rays of light, multiple modes of light. So they're just showing you this little pulse going down and how it is actually made up of multiple modes of light, and how those multiple modes of light travel down through the fiber. That's what we're seeing here. And my step index multi-mode, there's a pretty big difference of indices of refraction between the core and the cladding, so therefore the light is going to bounce its way down the fiber. Meanwhile, the multi-mode graded index, the core is just slightly smaller, and there's a gradual difference between the core and the cladding in the indices of refraction, and it's designed to bend the light and refract it back into the core, refract into the core, refract into the core. So there's gradual change between the core and the cladding, designed to coax the light back into the core, bend it back into the core, and therefore the light itself is getting coaxed down and is not being bounced down all harsh like. So yeah, I know that's a pretty bad description there, but it's being coaxed down the fiber, not bounced down the fiber. So the light itself is handled a little bit more gently as it moves down. That's your two types of multi-mode. The single mode is a very teeny core, very small. You can almost think it's like a coffee stirrer straw, very small core. So therefore, the light coming in here is no longer LED, it is laser. I have a focused light source coming into here that is being focused into this teeny tiny core to go down through the fiber, and because I have a focused mode of light, single mode, focused mode of light, going into a teeny tiny core, I've given it nowhere to expand or bend and all kinds of crazy stuff. So therefore, for the most part, is a nice, clean, single mode of light traveling down the center of this fiber. They call that like total internal reflection, if you really want to know. So there's my two main types, multi-mode and single mode, and then the breakout of stack, step, and graded index multi-mode. Well, I'm going to take it one step further. They eventually mention this to you, but I'm going to kind of pile it all here in one space for you. As I start looking at the different types of fiber, and I look at the core and cladding, we actually refer to them as the relationship between the core and the cladding. The core in our step index is our 62.5 micron diameter, microns in diameter. Well, let's pause for a second. I think I have out here a helpful hint, if you will. Microns are millionths of a meter, so 125 microns is roughly 5/1000ths of an inch, about that ballpark. That's about the size of a human hair. Here's a human hair, like 4/1000ths, 5/1000ths of an inch. That's about the size of a human hair. The outside of my fiber is about 125 microns, 125 millionths of a meter. Okay, so coming back here now, as I look at my multi-mode fiber step index, the relationship between the core and the core is 62.5, the cladding is 125. So the outside of this glass stub, this glass fiber, is 125 microns, and the core inside is 62.5, roughly half of it. So very large core in there for the step index. The multi-mode graded index, the core is 50 microns, a little bit smaller. So a little bit smaller core, but the cladding is still 125 microns. And last but not least, our single mode is 9 microns, teeny tiny core. The cladding is still 125. So this is showing you kind of the size relationship of the three right next to each other. Again, they scatter this through the next page or two in this part of the book, but I tried to compile them all here for you. So as we start talking different types of fiber, they'll either mention step index or graded, or they'll mention the size, and the sizes and the descriptions all go together here for you. I tried to put them all in one spot for you. And I put the sizes here, just kind of line them all up for you, step, graded, in single mode. And again, here's kind of, if I were to look at the end, the core to cladding on step, core to cladding on graded, and core to cladding on single mode, just to get it kind of a size reference for you. And there I tried to give you a little math to recognize the size of things. So here they show you a couple different types of fibers. I put down the three that you would most likely encounter on the previous pages. Alright, well, let's fill in a couple details on the multi-mode and single mode. Multi-mode fiber, this is typically going to be used in LAN uses, so most likely this will be the type you guys will encounter, connecting switches and closets together. So this is typical LAN use. And the light source is typically LED, that is a 850 nanometer light source. So short wavelength, short distance, LED light source, and pretty good bandwidth. And I can use up to, or I use LEDs, and then for higher bandwidth, I tend to use VCSELs, the vertical cavity surface emitting laser light source. Source emitting LEDs, if you will, excuse me. That's your multi-mode fiber. Your single-mode fiber, again, typically using laser light source. Now we're using 1310 or 1550 nanometer light sources. Longer wavelength, longer distance. Longer wavelength, longer distance. Okay, so these are typically getting used, or single-mode fibers typically getting used in MANs and WANs. Focused light source, small core, great distances on these light sources. And here they mention about currently we're using for the most part 5125 for gigabit links. That's kind of what things are being used right now. Alrighty, we'll come back in the next podcast and start talking attenuation and loss in fiber optic.